Right, so how do we calculate the resistance in an electric circuit? First, we look at them in a series circuit. So if I have n resistors in series, then the combined resistance R of the circuit is just the sum of all the resistances. For example, if I have like R1, R2, R3 up to Rn resistors connected in series, then my overall resistance R of this whole circuit is just adding up all the different resistances from R1 to R2 all the way to Rn. So the combined resistance R is always greater than the largest of the individual resistance because you add all the other resistances as well. Okay, let's look at this work example here. The figure below shows three resistors of values 2 ohms, 4 ohms, and 6 ohm connected in series to a dry cell of negligible internal resistance. That means we are assuming that there's no resistance here from the battery. What is the combined resistance of the three resistors? Okay, so these three resistors are connected in series. So the combined resistance is just the sum of all three of them. Okay, so we just add 2 plus 4 plus 6 and the total will be 12 ohms. Do you get that correct? Next work example here, we have two electric circuits. Figure 13.1, we have two ammeters connected in series with one fixed resistor. And figure 13.2, we have two fixed resistors and three ammeters all connected in series. So the question is, how do these currents in figure 13.2 compare with figure 13.1? Okay, take some time to think first before we go through the answers. Right? So the answer is current in figure 13.2 is smaller than that in figure 13.1. So why is this so? When similar resistors are connected in series, okay, the combined resistance is larger than the individual resistance of a single resistor. So here I only have one single resistor. Here I have two resistors. So my combined resistance is larger when connected in series. And when the combined resistance is larger, the overall current in the circuit will be smaller. Next, if our resistors are connected in parallel, then the overall resistance for the circuit is given by this formula here. 1 over R equals to 1 over R1 plus 1 over R2 plus all the way to 1 over Rn. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. N represents the number of resistors that are connected in parallel. And you find that the combined resistance R here will be smaller than the smallest individual resistance. Okay, you can plug in some values and then try out the formula and see for yourself. Combined resistance R is smaller than the smallest individual resistance. Okay, and the more resistors that are connected in parallel, the smaller the combined resistance R. So the larger the total current I, completely opposite of what you have in the series circuit. Let us look at this example in figure 13.3 where the two resistors R1 and R2 are connected in a parallel circuit. Okay, and they give you that the current I here is the sum of the two currents I1 and I2 in the two branches. So ammeters A1 and A2 show smaller current readings compared to ammeter A. Why? So A1 and A2 is measuring current I1 and I2. these two are smaller compared to the current I measured by ammeter A. Okay, so the current I actually splits into two currents, I1 and I2 at junction A. And when these two currents passes through the two resistors R1 and R2, they recombine back at junction B into the overall current I again. So you find that when the resistors are connected in parallel, the total current I through the battery is actually greater than the current in any individual branch. So you see, total current I is larger than I1 or I2 in the individual branch. So what does this show? In order for this current to be higher, that means the total or combined resistance here is lower. And for this I1 and I2 current to be smaller, it means that the resistance R1 and R2 here are larger. So overall, the combined resistance R of the whole circuit is smaller than the individual resistance R1 and R2. Okay, so combined resistance is smaller than the smallest individual resistance of a single resistor. Right, next book example. Find the combined resistance of the following resistor arrangement. So you have the two resistors, 10 ohm each, arranged in parallel. So we're going to use the formula 1 over R equals to 1 over R1 plus 1 over R2 for parallel circuit. And you substitute in your R1 and R2, 10 each. You get 1 over R equals to 1/10 plus 1/10, which is 2/10, 0.2. Then, to get R, you take 1 divided by 0.2, or you inverse it, you get 5 ohms. So the combined resistance R is 5 ohm in this example. Right now, your turn to do the exercises. Submit your answer in the next section below before the solutions will be released to you. Okay, so for exercise 1, you're supposed to find the combined resistance of the following resistor arrangement. So first, you need to identify whether they are in series or parallel, and then apply the correct formula accordingly. For exercise 2, again, you're supposed to find the effective resistance of the resistor arrangement. You find that this is a combination of parallel and series. So you will need to find the effective resistance of this parallel part first. Then it becomes a series circuit and you find accordingly. Then the other example, here you need to find the effective resistance of this part in series first before taking these two in parallel. So it's a two-step also.